Hello, hi everyone for this last technical session for the IEEE PES.
Okay, hello everyone. Welcome to this presentation in the IEEE Power and Energy Society Young Professional Regional Summit EMEA 2020. And the topic of this very important summit is digitalization in power and energy systems. And today I have the immense pleasure to be here and talk with you about technology convergence and the enabled technologies in energy systems. But before we start, let me take a very short time and explain to you who is this person. And I believe that the best way that you can identify a person is by using Google. And Google is very straightforward. If you look my name, Francisco Gonzalez Longatt, you will find around 39,900 results. And well, this person here is basically a full professor in electrical power system in the Department of Electrical Engineering, IT, and Cybernetics at the University of Southeastern Norway. And also, I started my new position at the University of Exeter at the United Kingdom. And finally, I am also the founder and the leader of Dehensis Lab. And Dehensis Lab is basically the short for real-time hardware in the loop facility laboratory and research that represent the Digital Energy System Lab. If you want to have more information about the Dehensis Lab, I highly suggest that you go to my YouTube channel and you will find a presentation regarding the Dehensis Lab. And before I start, I would like to tell you that in this presentation, all the concepts presented by myself belong to me, and as a consequence, any consequence of these concepts belong only to me. I am the only responsible of my opinions and my concepts during this presentation. Neither the university or the lab are related with that. And if you are watching this presentation and you want to watch the 4K version, you can go to my YouTube channel. Here at the bottom, you can see the link to my YouTube channel. And also all the slides, as usual, will be deposited into my ResearchGate repository. You can see here the link at the top. Also, if you want to keep the track what we are doing at Dehensis Lab, please follow my social media accounts on Twitter and LinkedIn. And again, The location of my YouTube channel is very simple. You just need to go to YouTube, and over there you will search Francisco Gonzalez Longatt, and you will find my videos over there. If you want to subscribe, please go ahead. Well, it's time to start this beautiful presentation about technology convergence and enable technologies in energy systems. But the idea is that there are many misconceptions regarding very basic concepts. And for that reason, I will start with the semantic. I will talk technology, technology engineering, digitalization, digital transformation, to enable technologies, the concept, and talk about several of those enabled technologies. Basically, I will talk about the battery scale utility scale batteries, behind the meter batteries, electric vehicle smart charging, Internet of Things, artificial intelligence and big data, blockchain. Finally, the closure related to technology convergence. Well, it's time to start with the semantic. Let me start making clear some of the concepts, okay? You must understand first, semantic is the study of meanings, reference, or truth. That is the basic concept of semantic. And semantic can be used to refer a subfield of several distinct disciplines, including philosophy, linguistics, and computer. Here, I will just do a very basic explanation about very basic concepts that we use every single day, but perhaps we are not using in a proper way. Let's start with technology. Technology is one of the concepts that in the recent time has been around every one of us. And if we go for the Oxford Dictionary, the technology is the application of the scientific knowledge for practical purposes, especially in the industry. And this concept must be not be confused with engineering. If we go to the IEEE 100, the authoritative dictionary of IEEE standard terms, you can find the definition of technology. And the IEEE 100 define the technology like the scientific knowledge used to archive to achieve a practical purpose. What we can see over here is that technology is something practical, but with the use of the scientific knowledge. And something that you must understand is that technology is not inherently good or bad. It's the culture that we build around the technology and the way that we use what make good or bad the technology. After this clarification, I need to go into two very confused terminologies: technology and engineering. As I said before, technology and engineering, they are terms that they are extremely close relate each other, but frequently we make the mistake and confuse one with the other. We need to understand that the engineering is the activity of applying scientific knowledge to design, building, and control of machine, roads, bridge, electrical equipments, and so on. As a consequence, you can see that engineering is applying the scientific knowledge. Engineering is the mind and effort into making something, and technology is the result of that application. That is the very simple difference. Engineering is all when you are using your mind, your brain, all your knowledge and wisdom to make something. And the product of that is the technology. In other words, engineering is more specific than technology. Engineering is a problem where the technology is the solution, and the technology it will be used over and over again. For that reason, we don't need to we don't need to confuse and mistake the concepts. Technology is the consequence, engineering is the way that we produce technology. And here you can see a very beautiful plot that you can see the technology evolution. And the technology evolution is based on applying engineering to create something. For instance, in 1971, that was the year for the first microprocessor. In 1976, that was the year for the word processor. In 1980s, Microsoft launched the famous MS-DOS of Microsoft Disk Operating System. In 1975, Microsoft established a company with right now is with a capital of more than 41.67 billion. In 1985 appeared Windows. In 1990, you can see that is the sudden appearance of the World Wide Web. And in 1973, we have the first mobile phone. And in 1999, we have the hybrid car. In 1998, Google reached a capital of 181 billion US dollar. Facebook was founded and in 2004, and right now is a company with a value around 85 billion US dollar. And finally, in 2005, you remember YouTube. YouTube was launched in 2005, and that is another technology company that is basically with a capital around 20 billion US dollar. If you can keep going, if you want to keep going, well, in 2010, that was the appearance of the famous iPad. But one interesting question is the technology good or bad? Well, to be honest, the oldest fire record on Earth has been identified for some very old cave, and that we are talking about more than 420 million years ago. However, the fire was something that the humans we used to create heat in order to create light during the nights and to avoid the wildlife and so on. That was very, very good. However, between 1942 and 1946, the famous Manhattan Project was a research and development project undertaken during the World War II, and that was to produce the first nuclear weapon, and that was a capital of 3.3 billion US dollar. That you can think about is a human development. I will not say if this is good or bad. This is for your personal reflection. Okay, there is another very important project, the Project Genome. The Project Genome was an endeavor that ultimately aimed to determine the complete genome sequence of organisms. To be honest, that project ranged for 1 decade with a capital of 2.7 billions. And with that, what we try to do is reach next level in human development, know more about the human life, know more about the genes, and as consequence, that can be positive because, for instance, we can identify some kind of illness very early or even before the human being is alive. However, it can be also used for bad things. For instance, right now there is a tendency to talking about what we call the biodigitalism. And the biodigitalism refers to the mutual interaction and integration of information about biology. In particular, it is investigate biological future through biodigital technologies, including molecular diversity and the novel synthesis of the DNA constructs. That means that we are using engineering in order to create biochemical pathway or genomic. Is this good? Is this bad? Again, this is something that is a human development, is something that depends on you. But now I would like to make the clarification between digitalization, and digital transformation. What is digitization? Well, you can see over here, digitization is making things digital. The process where we are taking a signal or something that is in analog signal and is converting them into the digital world. And the digitization takes this kind of process from the analog world into the digital form. But that represents a huge advantage. For instance, we can see here that process when we used to have everything on paper, but right now we have electronic documents. In the past, we have the very slow mail, and right now we have the fast email that is moving through the internet. In the past, we have the old technology that was the fax. Probably many who are so young that they don't remember the concept of fax. But right now, we have the e-document. And finally, for instance, the past is basically anything that is in analog form. Present is using one and zeros, I mean digital technologies, to represent the same type of information. In electrical power grids, well, digitization has this meaning. Basically, we are transforming the electrical power grid, we are transforming the measurement, the process, and so on, and that means converting something into the electrical form. And to be honest, here I have a very clear effect. Here you can see this is the classical representation of a protection ID. And as you can see over here in a classical protection using the concept of analog, we have the classical current and voltage transformer that they are sensing and they are adapting the voltages and current, low level power that is required by the ID. And when those analog signals reach the ID, they are converted and they are using inside the protection relay in order to protect a very specific device. Of course, during this protection function element, we can generate reports, or also we can have an interface that is sending a trip signal to the circuit breaker. But this concept is this is basically analog concept. Right now we are moving to the digital substations, and in the digital substations the concepts are changing a lot. Right now we are making the electrical signal, voltages and current digitals, and now we are using a technology that is called non-conventional instrument transformers. And those non-conventional instrument transformers, they can automatically convert the analog signal that is coming from the power system, voltages and currents, and they are converted into a data stream, a digital data stream. And using the concept of the IEEE 61850, for instance, we can use that communication protocol, that data structure protocol, and so on, in order to transmit those digital data stream into the protection or the ID. What I'm telling you is that the concept of the digital substation, we are receiving data streams with 1 and 0s, and then have inside data package representing the voltage and currents. And now we simplify this concept of the digital protection going directly into the protection functions, and also having this protection interface. In this digital concept, also the trip signal can be a digital signal. And in that case, we are using a very specific part of the IEEE 61850, that is the goose messaging, in order to order the trip of the power circuit. And here in this arrow, where when I say that we are sending data string with packet related to voltage and current using the 61850, I am talking about one very specific section of the protocol that is for sample values. What is interesting is that this transformation is going really fast inside many electrical power systems around the world. And the digital substation market is expected to be more than 8 billion US dollar in 2019, and it's anticipated that the rate of growth of this market will increase fast by 5% until 2026. What I tell you is that this digital substation, they are not a dream. They are already working and being used in several countries around the world, and that is a reality. But now the question is, what is digitalization? Well, the digitalization is basically using the digital technologies in order to enhance a process. Many people look to the digitalization as a market opportunity to make the business more profitable, or also to create another kind of business. And that is where we are talking about the digitalization. Electrical power systems, they are subject of these new business opportunities created by the digitization. And for instance, the generator side is only at the very early stages of this process. They are modernizing the power plants, automating some of the grid controllers, and so on. In transmission system, probably we are in the most advanced characteristic, because we are taking many of advantages of many of the digital technologies, machine learning, artificial intelligence, optimization, and so on, in order to make more efficient and more transparent the transmission system. Distribution system, well, distribution system is still in early stages. However, it's moving extremely fast by the full automation of the grid, by the stability and optimization. Utilities and prosumers, they are very interesting concepts. Prosumer is basically the change of the behavior of the passive customer that we have in the past, but with the conscience or with the knowledge about self-generation and self-storage. What I'm telling you is that that very old concept of a customer just requiring energy from the electrical grid is something from the past. The customer today generation PV solar panels that they are in the property. They have also the possibility of battery energy storage. They have the possibility of those amazing electric cars and also the heat pumps. As a consequence, the customer have the possibility of changing the load profile in order to enable flexibility to the grid. As a consequence, there is a new kind of business opportunities coming from this digital era. The concept of virtual power plant, the aggregated balancing, and so on. What I tell you is that we can think about the digitalization that provides several advantages. For instance, they can enhance the main grid stability and reliability because they allow better monitoring of the grid and identify point of failures and so on. But also the digital era allow us to optimize and forecast the energy production, and that is helping the utilities to cope with the variability of the weather-dependent generation located on the customer. On the other hand, the digitalization allows the customer to have more control. Now the home energy production system like rooftop solar panel can be matched with a smart home energy management to enable the owner to join to the local microgrid or blockchain scheme. And finally, manage, distribute, and behind the meter generation is one of the other advantages of this digitalization, because that allow to have better control of more distributed and decentralized generation systems inside the electrical grid. Here, there is a current example of the status of the digitalization in the energy value chain. As you can see over here, we can see that the concept of a smart grid is applied for the whole energy value chain, but for instance, we are taking advantages of the digitalization when we are talking about renewable energy generation forecast or the automatic controller of power plants. Transmission and distribution, the digitalization has allowed to maintain the grid stability and enforce the reliability with better characteristics for monitoring and control. And also to the consumption, well, we have more control for all those aggregated very distributed energy resources. As a consequence, we are optimizing everywhere the electrical system using these digital technologies. What is important is that the digital transformation is changing the model, the business model inside the electricity industry. As you can see, we are using those digital transformation to create impact on the business. That impact in the business can be done by creating gains on the efficiency, maximizing the revenue growth, or avoiding any kind of legal fines or growth. That we are increasing the advantages and the positivity of the electricity industry. But now, what is enabling technologies? Well, enabling technologies is probably one of the concepts that is very complicated to understand for many people, and that is confused in many places on the internet. In order to define in a proper way the enabled technology concept, I will take the advantages of the European Union Commission. The European Commission defined the enabling technologies as an invention or innovation that can be applied to drive a radical change in the capabilities of our user or culture. Again, this is something very specific. Enabling technology require an invention or innovation, and the target is to create a radical change. We are not talking about very small change or very small change. We are talking about radical change in the capabilities of a user or culture. And enabling technologies are characterized by very rapid development, and consequent, you will have so many other derivative technologies called derivative technologies. Okay. Now, enabling technologies is a very wide concept. But the European Commission established key enabling technologies. And that is where the European Commission is putting all the money for research and development, specifically for the industrial technology program. And in this case, we can identify several areas specifically for nanotechnologies, advanced material, advanced manufacturing and technology, and biotechnology. But now, if we go to the electrical power system, if we go to the electrical power system, what are the typical location for the enabling technologies? Well, enabling technologies can be located in many places. However, you can see here that in the generation side, we can talk about the use of the computing power. As the power system is dynamically changing and the characteristic of the power system is a very high complex non-linear system, computational power is one of the main issues. And then we need a lot of speed in order to transfer the data and information inside the electrical power system. And that is the reason that connectivity is another enabling technologies. And when we are talking about enabling technologies for connectivity, we are talking about advanced application of mobile and internet and also 5G and 6G. Sensors and data is an area that has been in development in the recent era. And inside the sensor and data, there are several enabling technologies. The proliferation of data, the increase, the growth on volume of data, and the decreasing of the cost of the sensor by using Internet of Things, it's enabled the massive deployment of those sensors and receiving so much data almost in real time. And finally, software is a key component of the enabled technologies, and inside the software development, we have the machine learning, the blockchain, the big data, and the artificial intelligence as the main elements of these enabling technologies. Okay. Now, what I will do is I will use a report coming from the International Renewable Energy Association in order to discuss some of the most important enabled technologies. As you can see over here, these next slides are based on the International Renewable Energy Agency, and they consider several aspects that we can consider as enabled technology. Utility scale batteries is a game changer, but also small batteries behind the meter are a game changer. Electric vehicles with smart charging, they are considered also enabled technology together with Internet of Things, artificial intelligence and big data, and blockchain. I will try to cover some of them in the next 30 minutes, and we will start with the enabled technology based on the utility scale batteries. Utilities scale battery, okay? By 2017, I mean, few years ago, 10 gigawatts of battery energy storage was deployed worldwide. However, as the cost of the battery has been decreased over the time, and also as the technology has evolved very fast, well, the use of very big batteries, utility scale battery, and we are talking about several megawatts for several hours, they start to be important and be included into the electrical system. And those new batteries that they are installed at the utility scale level, we are talking about the lithium ion batteries, that they are probably the most mature and the most persistent technology in the system. But what is the main characteristic? What is the main characteristic of those utility scale batteries? Well, they have very reduced upfront cost, but also they require that those batteries must be located and used for very specific services. For instance, those utility scale batteries can be used together with renewable generators in order to reduce or to avoid the curtailment of those renewable generation. And also, together with renewable generation, the utility scale batteries they can offer the possibility that the renewable generation offer a capacity firm. Okay. However, there are many other applications that we can find utility scale batteries, like frequency regulation, flexible ramping, black start, and so on. What is interesting is that the batteries in the United States, for instance, there are many demonstration projects in the US. And for instance, a 4 megawatt battery for a 40 megawatts hour capacity can be able to save 2 million US dollar in fuel costs over 400 hour connection. And now let me talk about other very important enable technology, and that is basically the batteries, the small batteries that we can install inside the houses, and that is what we call the battery behind the meter. Battery behind the meter is not a new idea. If we consider that 40% of the recent rooftop solar photovoltaic system in Germany has been installed with batteries behind the meter, and more than 21,000 of battery behind the meter has been installed in 2017 in Australia. What I am talking is that for the case of Australia, they are thinking about 1 million of those batteries behind the meter by 2025. And in this case, the battery behind the meter can help the customer to decrease the utility bill. That is done by appropriately controlling the charging and discharging the battery in order to create, together with the demand side management, a reduction to the electricity that is imported from the grid. In other words, installing those battery behind the meter is one way that we can increase the demand flexibility, and that unlock the possibility of installing more and more renewable, especially on the secondary distribution system. But one interesting thing is that the digital technology can allow the control of those battery energy system behind the meter. And if we appropriately control those batteries, well, we can create a massive virtual aggregate battery that can provide support to the system operation while also some networks capacity installment or the peak capacity investment. Another important enable technology is the electric vehicle, but with the smart charging. If we consider that 5.6 million of electrical vehicles were on the road in 2019, well, we consider that there is a lot of possibilities of using the way that those electric vehicles are charging. And that is what we call smart charging. Smart charging is basically intentionally and efficiently modifying the peak load during the charging process to avoid many things. One of them can be avoid the grid rainfall. And but there are many other ways that this service can be used. For instance, to reduce the network congestion, the peak shaving, the provision of auxiliary services, and that is where the concept of electric to edge, that means to anything, start to be interesting. Well, on the other hand, another important enabling technology is the Internet of Things. The Internet of Things being enabled to reach the full level concept of smart grid through the collection, transmission, and use of large amounts of data. But it's not also the collection, transmission, and use of amount data. It's also integrating many of the customer togethers with the system provider, with the services provider, with the generation providers, and so on, in order to increase the flexibility. In that sense, the Internet of Things can be used for many things. Can be used, for instance, for interconnecting or making transactions between providers and consumers of the services. In this slide over here, I am showing you the Internet of Things concepts inside the what we call the smart grid. In the center, you can see over here here, the transmission and distribution grid, but also from the information point of view, we have the data center. And around of this, you can see Internet of Things used for advanced metering infrastructure, and that is transferred to the data center. We are talking about the integration of those advanced metering infrastructure, wind power plant, solar power plant, fossil fuel power plants that they will disappear, smart building, electric vehicles, and so on and so on. What I'm telling you is that Internet of Things is one of the very interesting enabling technologies. However, we need to be careful with those technologies because also there are some areas that we need to take into consideration. And cybersecurity and data protection is one of the key issues related with this technology. Well, now we are going to another of the enabled technologies, in this case, artificial intelligence and big data. In recent time, artificial intelligence and big data has been very, very important because what we are trying to do is make the machines, make the computers behave like a humans. An artificial intelligence system change the way that we are behaving inside the system. What I'm telling you is that artificial intelligence try to replicate the behavior of the human beings, and they have successfully delivered a very good response for many tasks that we are doing right now with humans in the electrical system. In the future, I can see clearly that artificial intelligence will take over many of the decision-making processes that right now we are relying on humans. However, I must be honest, I don't think artificial intelligence alone will work forever, because there are many things that we still under development regarding of artificial intelligence algorithms. For instance, one of the things that is very important is that the human has the possibility of taking decisions without any data or with a very reduced amount of data. That is something that we cannot do when we are talking about these artificial intelligence algorithms. What is important? What is important is that this artificial intelligence also have a really bad side. For instance, when we are talking about For instance, if we think about this artificial intelligence, we require electricity for training the algorithms and so on. For that reason, we need to think about the energy footprint of this kind of new technologies. What is important also is that with this artificial intelligence and the big volume of data, well, there is a growing importance for the cybersecurity, for the ability and quality of the data, and so on. Well, finally, I have here one of the enabling technologies. In this case, this is the blockchain. The blockchain is a very interesting concept. As you must be aware, the power system complexity has been increasing and increasing. And in order to work with a so complex system, intelligence must be applied. And blockchain is one mechanism that can help by managing data more openly and more secure, while automating transactions via smart contracts. What I'm telling you is that the core of the blockchain is the informatic infrastructure, the communication channel, and those smart contracts. And those smart contracts, they are created to ensure the 100% realization of the transaction. And right now, well, if you look some numbers, there are many companies worldwide that they are using blockchain in energy. In the report that is coming from Arena, we are talking about 189 companies already using a blockchain in energy. 71 projects were focused on blockchain energy for a total of 466 US million in this technology. And we are expecting that this technology will take over in the future, enabling the real-time market operation. Here there is a summary. We need to be careful about those concepts. Artificial intelligence is basically for decision making processes. Internet of Things is basically a mechanism for data generation because it's consolidating the granularity data captured by many sensors. And blockchain is very important because it's the way that we can ensure the transactions. What I'm telling you is that these three technologies together, they are enabling the future digital energy system. Well, we are almost finishing this presentation, but I need to talk about technology convergence because we are here for technology convergence. And let's start first understanding the concept of convergence. Convergence is a deep integration of knowledge, tools, and so on that allow the society to answer the question to change regarding physical or social ecosystem. And the technology convergence is basically a mechanism that allows the society to a tendency or phenomenon where two or more independent technologies are combined in order to get one. What is the best example of technology convergence? Well, I must tell you, what we call the smartphone or the today's mobile phone is basically a convergent technology because probably you are too young for remember this, but many years ago we used to have a device that was called calculator. We used to have a device that was called music player. For instance, Apple have what we call the iPod. And many years ago we used to have a camera, an internet that it was based in PC or personal computer. But right now we have in a single device many old technologies that used to be individual technologies. What I'm telling you is that the mobile, the smartphone integrate many technologies that in the past they were independent and separately. And that is true. What I'm telling you is that the technological media and network convergence is a reality. Right now, we have media convergence where we have different kind of content provided in a variety of formats, and then together with the network convergence, we have a different type of protocol formats that they are transmitted, and finally we have a technological convergence that is the device. The technological convergence is the device. In this case, we are talking about the famous smartphone or the famous Internet of Things or smart cities or so on. The digital energy transformation is a reality in electrical power systems. In electrical power systems, the transformation of many technologies is taking a very important aspect. On the left-hand side, we have digital technologies. You can see here Internet Things, 5G network, cloud computing, big data, artificial intelligence. In the middle, we have the technology convergence, and we are talking about the emergence of new resilience, security, and reliability business models, minimizing cost, and everything is on the energy technology. And in the energy technology, we have many very interesting things like wind power, solar power, prosumers, demand side customers, and so on. What I'm trying to tell you is that we are changing the way that the system is behaving. For instance, hydrogen start to be one of the very key, very important game changers in the electrical system. And we need to take in consideration that in the future, many of the technologies that we are having right now in a separate way will be convergent in a single device. Well, this is the closure, and I would like to show you, a couple of slides regarding something that we have been doing in the Digital Energy System Lab. As I am running the Digital Energy System Lab, well, I always say, why not use the digital technologies to do something different? And one of my target was in during the previous years, I have tried to create FG Longatt 4.0. Here you can see my first avatar created. It was basically a 2D avatar that was able to take my place in some conferences, okay? And then I start to increment the complexity of the models, and I start to create what I call the FG Longatt 4.0. And this is an avatar that is 3D and is totally able to modify the behavior based on a 2D photo. And finally, here is the most recent version, of course. In this case, you can see the digital technology that I create, a avatar that can be present in some conference where I cannot go. And well, what is the takeaway from here? The takeaway from here is technologies are there. And for instance, today, many people people are involved in what they call TikTok. TikTok has been installed in 2.6 billion of different devices around the world. But now the question is TikTok helping to solve the real problems that we are having in the society? If you look on the right hand side here in this slide, in front of you, we have the 17 goals to transform our world. And it's a reality. We are in a climate emergency. The impact of 1.1 Celsius degree increase is extremely bad for the society and for the world. We are talking about increased frequency and magnitude of extreme weather events like heat wave, drought, flooding, winter storm, hurricane, and wildlife. What I want is that all of you take the best from the digital technologies. Take the best from the digital technologies, but not for just learning and using. I need more innovative thinkers, people that they can solve problems in a different way, creative problem solver is something that we need to embed in the mind of the young people. We need to have a different way to think in order to have analytical approach, in order to have analytical approach, in order to solve the problem, and of course to make the world better. Well, I think this is the end of my presentation. This is the end of the presentation, technology, convergency, and enable technology in energy systems. And again, my takeaway over here is, as I started, technology is there. Technology is not good or bad. Humans, they use the technology for something good or for something bad. Try to use the technology in order that we can reach the next level and solve problems. We need more engineers, because engineering is what is creating the technology. And that is where we need young people developing different skills and different way to think in order to solve the problem. Well, this is the end of my presentation, and that was my takeaway. Thank you very much for be present in the IEEE PES Young Professionals 2022 Digitalization in Energy and Power. Thank you very much. It's time for question and answers.
Thank you, Mr. Francesco. Really, it's very good presentation. Is there any question? If there is no question, so we'll close this technical session number 4, and this will be the end of our Congress. Thank you very much for attending this first edition of IEEE PS Regional Summit for Europe, Middle East, and Africa. I hope to see you again in future events. If you want to volunteer with the PS, just you can reach out to me. My name is Ayman Tmar, the IEEE regional representative. Or you can contact our website, Facebook page, or any our social network website. Thank you very much, and bye bye.